Hey guys, good evening.
Hey,
Hey, how's everyone doing?
great actually.
But let's gather some topics for today. So one of the topics, of course, is the committee elections. The voting process started last week. And let me find the link here.
Making the announcements.
That's right, in the announcement. Thank you. So if I interpret this number correctly, 48 people have voted. Please cast your vote here. 48 people voted so far. This was configured. Everyone gets 5 votes. You can cast a maximum of 3 votes per candidate, and voting happens anonymously. And up to this point, even I can see how many votes individual candidates that will all become clear at the end of this month, with 30th of April. That's when we'll see the election results. Anyone and everyone who's watching this video once it's recorded, please go to this URL. I'll actually share it in the YouTube video in the description below to make it easy. That will be good. So, status. Let me remind myself by looking at... By the way, if anyone has any topics or demos they want to discuss or demonstrate, I forgot what this was. Let me know. Composite Activity timer. I know Mohammed's been working on a CRON UI. Mohammed, maybe you want to demo? It will be interesting.
Yeah, I was trying to prepare the demo. Unfortunately, my PC just crashed. So now I'm logged in from my phone. Maybe next time I will show.
Sure, no worries. Next time will be great. So I made a few notes for some ideas for a quick demo today. I know Frans, you opted maybe talk a little bit about securing HTTP endpoints and the API controllers in general of Elsa. I didn't have time to prepare anything for that, unfortunately.
Okay, no worries.
I did make a note here. SwaggerGen support for HTTP. I would like to show that. That's a new feature that got in recently. This one here. So this is a new feature and enhancement to the HTTP endpoint activities module, which allows your HTTP endpoints, as you add them to your workflow, to become part of the open API generated by Swagger. So let me show you how that works. I have the server running here. Now let's take a look at it. Swagger documentation. So by default, when you enable Swagger, it will generate endpoint documentation for the installed API controllers. This all comes from Elsa server.api, and of course your own controllers if you have them. So as you can already see, it adds a new category here called workflow endpoints, and this comes from that new feature. Currently there's no endpoints, but let's add one. So let's create a new workflow starting with an HTTP endpoint, and let's say that it supports the get and post verbs, and let's publish this one. And now switching back to Swagger, and as you can see, now those two HTTP endpoints, they appear as legitimate endpoints in the documentation. It's very bare bones, as you can see. It doesn't say anything about parameters or responses. You have some control over that. For example, let's say this HTTP endpoint accepts a custom model. So let's go to... So this is the assembly qualified type name. And now, if everything went well, I refresh this page, it should now show the schema, and this is correct. So this model I just entered, it has a single field message, and it's displayed here. And this is a bug. It shouldn't display this request body for get. So it still needs some polishing. But the basic functionality is there. To be clear, it's actually not added to the XP package itself. It's an add-on package, or it's an additional package you have to install to enable this. So it's not there by default. But if you install this new package, it will not automatically work. You will have to install this document filter.
Actually, I don't think that's a bug for the cat. In the official documentation for the verb, you can put a body in there.
Oh, really?
Even for cat, yeah.
Oh, I didn't
So
know.
I wouldn't do too much about it. It's
no, in that case,
quite forgiving.
Yeah, indeed. Well, in that case, I'll just leave it in.
I'll double check it once more, but I'm pretty sure that it's allowed to have a body on a cat verb.
Okay. Have you ever used that?
I had to use it because someone implemented it like that. I wasn't too happy with it though.
I wouldn't be too happy with that either. But then again, if it's a valid use case, maybe we have something to learn there.
Yeah.
So when you want to enable this feature, first is, of course, installing the packets, and then you need to add your Swagger services. Here I'm using add Elsa Swagger, but you don't have to. Internally, it just installs a opinionated configuration of Swagger. So it's doing things like adding a few examples, setting up the Swagger doc, that kind of thing. But it's optional. You can do this yourself, so you don't have to use add Elsa Swagger. But you do have to add this document filter in order for the HTTP endpoint integration to work.
Do you have any ideas or plans about the response type as well?
You mean, so this is the request body, but there's also the responses. I think I may have even added a note. I didn't add a note, but except for additional work might be done. And that should include being able to control or document the response, the possible response type. We have to think of good ways to do this, because right now there's some things you can configure on the HTTP endpoint, like you can give it a display name and a description. This description will actually show up if it works. So it doesn't work. The description should be applied.
Should publish?
Maybe not.
Okay.
Yeah, well, that could be a bug or an omission. But that's one field that can be used, of course. But in terms of a response, the question is, where would you document it? Do we add a field here just for the purposes of describing the response? Maybe. Of course, the response will be controlled by an HTTP response that actually performs the response, but you might consider this as the body implementation of your API controller, if you use that as an analogy, in which case might be completely valid to configure your documentation here. I don't know. We have to think of it. It will be convenient though. Maybe the packets could provide an extension to this activities UI that can install, for example, an additional tab called Swagger or OpenAPI and install a bunch of fields that you can use to configure OpenAPI. That might be nice. Otherwise, if we bake it into this HTTP endpoint, you have these fields for no other purpose than to provide description to the OpenAPI generation, even if you're not using that. But it's a good question.
Yeah, I'll think about some strategies for that.
Yeah, that would be great.
Distill it from the workflow, or that you can distinguish it there somewhere. But,
yeah, that's also a good suggestion, to maybe not link it to this activity, but as an extension maybe to this general settings.
Yeah, exactly.
So just circling back to status for a bit. I know Mohammed's been working on an improved CRON UI, so we'll hopefully see that next week. I've been working on Elsa 3, specifically on the Proto Actor runtime. And for those who haven't heard of Proto Actor, it's a very, very lean and small footprint library that allows you to implement actor model. Maybe some of you have heard of Microsoft Orleans. Microsoft Orleans is a .NET library that allows you to implement the actor model. And what is the actor model? Is simply put, it's an object that you have which has its own inbox, and this inbox you can regard it as an input queue. And when would you use it? You would use it in a distributed environment. So let's say you have a cluster of applications or nodes, containers in a Kubernetes cluster, for example. And each of these containers can have one or many more actors, and they will process this input queue. So these queues contain messages or operations that the actor can perform. And what I want to do for Elsa is to leverage this model, because I think it's a great fit for processing workflow instances. So as you may know, with Elsa 2, you can host it in a cluster. What needs to be taken into account is that the state workflow instance should not be updated from different threads, for example. We could run into issues where, with concurrency, let's say 2 threads are working on the same workflow instance, then one performs an update and then saves it to the database, while the other thread has it still in memory, now has a stale copy in memory, makes changes to it that was written by the other thread. Simply put, to avoid that, Elsa 2 uses distributed locking. So here it talks about a distributed lock provider, and basically what that means is, as soon as the engine wants to start working on a workflow instance, it will first try to acquire a lock using, for example, a lock in SQL Server. which is a shared resource, which is why it works, because any node in the cluster will try to acquire the same shared resource or a lock on a shared resource. And then you can imagine if a second node in the cluster tries to also update the same workflow instance, it will first try to acquire this lock, but it will fail to do so because it's already taken. So it will wait for a configurable amount of time before it gives up. Usually workflow instances are supposed to execute quickly, so the lock should be released quickly as well, which means things will work out. In extreme cases, it won't work out, and then the second thread will just fail to update the workflow, and then either depending on what caused that thread to work on the workflow, for example, if it was because of a new message received in some queue, then that message the lock will be lost, and it will just be delivered again, and then a worker will get another chance to update the workflow. If it was an HTTP client, then that client will receive a exception or an HTTP error, and then the client will have to try again. But usually it works out. Distributed locking works. It's pretty great and reliable, but it has one disadvantage, and that of course has to do with throughput. Because of the shared locking, it becomes, you can process a smaller number of workflow instances when you didn't have to lock. And now the actor model, it allows you to not have to deal with distributed locking because every workflow instance will have its own input queue, and all communication with the workflow instance goes through this input queue. You can have many sources that instruct or send instructions to the workflow instance to perform some operation. The workflow instance actor will only process one message at a time. So of course you can have many thousands of workflow instances spread across your cluster, and they will all happily process their input.
So each workflow instance is going to be one single actor. That is a one-on-one relationship between those.
Exactly. Yes.
And also, because when I looked at your documentation, I saw it was a log thing for the SQL Server. Mm-hmm. I don't think that, because that's a part of the SQL Server itself, the logging mechanism.
Yeah.
And so you can't have that distributed logging for any database. Some might not be able to have that feature.
Right.
Or it's not implemented. So the actor model also allows you to have any database and still have that same pattern.
Well, so of course, if you're working with Elsa 2 and you need distributed locking, but you can't leverage the SQL Server, there's other implementations. So SQL Server is just one example. Elsa actually uses it should instead .NET packets I think it's called distributed locking. Distributed lock, that's the name, and they have many providers. So you could use a blob on Azure, even the local file system, but that's only useful for single node machines, I imagine, or maybe network shares, I don't know. And of course, Redis, etc. It has a bunch of options. But for Elsa 3, we don't need distributed locking, not typically in any case, because the actor model out of the box just uses an in-memory mailbox. My initial concern was, well, what happens if the container goes out of commission or there's some system failure? What happens to all my queued messages, right? But for that, they have a thing called persistence actors. And what that basically means is that as your actor receives a message, you write it to a persistence store, and then the framework, the Proto Actor 1, 2, 3, ensure that whatever is stored there will be delivered to your actor. And the only difference works with event sourcing and snapshots, pretty fancy stuff. Quite easy from the developer's point of view when you develop the actor, but the gist of this is that all of your state gets persisted in some underlying persistence store that's pluggable. And this could be your own database, it could be Kafka. I don't know, I've yet to dig into the detail.
Yeah. That also, if you implement the persistency on the actor, that will also reduce the throughput, and it will affect it at least.
Yeah, for sure. It will be slower than when not persisting anything and just keeping things in memory for sure. But the good thing is it wouldn't have to do any updates depending on the underlying storage. For example, if you use Kafka, you would just be writing events and that's it. So you would only be creating records and never updating. So then you have a bunch of events being written, and at some point a snapshot gets created. And the framework allows you to refresh your actor from this snapshot, and it replays any events that were not yet part of that snapshot, which is pretty fancy if you ask me. I think it's yeah. Here's some documentation. Well, I've been going through this for sneak preview. It's the runtime Proto Actor implementation. And 1, 2, 3. And then so let me clarify. A thing called grains, which is another word for virtual actor, which is a term borrowed from Microsoft or Orleans. And what's great about a virtual actor, it means that as a developer, you don't care about the location of where this actor is instantiated. It could be on node 1, could be on node 3, or whatever, how many nodes you have. You don't care about that. You don't even have to care about the actor being activated or not. You just treat it as if it's a service or an object that's there. The framework will make sure of activating it and also passivating the actor, which means if let's say a minute after the last message was received by some actor, it will be removed from memory. Logically, there will be one workflow instance grain per workflow instance. So you could have many hundreds or thousands of them processing workflows all in parallel. It's pretty awesome. Removing the need for distributed locking and ultimately allowing the system to scale enormously. And I know that, well, I've read stories about Microsoft Orleans using their system for, I believe, the game Halo. It contains many objects and they leverage the actor model successfully. Yeah, so I've been getting into the nitty-gritty details of that, and that's to be dialed in soon. Everything else is coming along nicely with Elsa 3. Together with this item, the Proto Actor runtime, I'm also working on a couple of other activities like the break activity, for example, allowing you to break out of a loop. So here there's a small integration test with this little workflow. It starts with a write line and then a for each. Here I have some arbitrary logic that says if the current item is Rust, so here I have a list that I iterate over, so it's 3 languages, and I want to break as soon as I encounter this value Rust using the break. And that what should happen is as soon as it should not continue on with the write line activity, break out of this for each loop and continue with this one. Currently the test fails, which makes sense because this is not yet implemented. So speaking of clusters, I thought maybe it might be helpful to see how would you test your configuration in your local machine, because it can be tricky to test in a production environment or even a test environment. What I do, I use Rider for that, and Rider has this nice feature called configurations. So here I have it's like the launch settings that you have here in properties. There's launch settings, JSON. This setting, I believe Visual Studio Code has it as well. You have profiles, if you will, configure them, want to start environment. But it also has compound profiles. So here I created a compound profile consisting of 3 configurations here. So they are here as well. So they're server node, and they are basically copies of server. Container name. And why do I have different container names per node? That has to do with messaging. So let's say I have a domain event that I want to distribute across all of the container instances in my cluster. Each node needs their own input queue, because if you don't, then it will be you will have basically the competing consumer pattern in place, where the first container or the first node in your cluster to pick up this message will consume the message, and none of the other nodes in your cluster will be aware of this message. So this works great if you want to distribute work, and that's exactly what you want. But if you want every node in the system to receive event, then they need to be listening on their own input queue. And Elsa uses this container name to generate the input queue. So one nice aspect of having various configurations per node, and then using the compound configuration here, you can start all 3 instances at the same time. So here I can say, and this will then start 3 instances of my application. So as you can see here, there's now 3 instances. Node 1 listening on this port 12100, 122. And what's nice about this is it allows you to test if you configured things correctly. So for example, let's go to the dashboard. I have it open here as a separate Rider instance. Now let's say I want to connect to node 1 port. So I'm updating this. Hot reloading will update the dashboard. So here we have the dashboard, and as you've seen, this is communicating with the server listening at 1 to 1. Actually, I wanted to also show the, okay, let me see if I can test it like this. So now let's say I'm changing the name of this workflow definition. Let's give it a name, point, I'll publish this. So what happens when I publish, a event will be generated that should be delivered across all 3 nodes so that their cache gets invalidated, because what happens if you look at the workflow registry, this workflow registry, the items within it are cached using a local memory cache, and then whenever a change gets made to a workflow definition name or anything else changes in the workflow definition and you publish it, a signal gets distributed across the nodes. Each node gets a chance to invalidate their local memory cache. So that means if it works and I connect now to a different server, so now this has connected to a different server, that means that if I load the database workflow provider, it should show the updated name, which it did in this case. And to be clear, making requests from this page to the server does not invalidate the cache. This test is successful. It will be even better to test if you also launch 3 separate instances of this client. But for that, maybe you can launch not the server cluster, but the monolith cluster, because that is that hosts both the dashboard and the workflow server. We can actually give that a quick try. So here we have number 1, number 2, and number 3. So let's take a look at the workflow registry for each. So now let's do the same test. We'll change the name of Hello World 1, and publishing should have invalidated the cache. So let's refresh the second node, and as you can see that and the same goes for this one, also Hello World 1. So this is an easy way to test your distributed setup. Testing workflows, have you guys tried this before? I guess that's a no. So let me.
Well, what do you mean with testing?
Okay. Well, good point. I think Elsa there's a new feature that allows you to run a workflow from within the designer using which has a button to execute your workflow, and then you can see it run step by step. So this is not a very exciting test, of course, but it also works if you have multiple. Add more. So now with those in place, I can go tap again and then execute, and then you see each one switching back to the server. You also see, of course, the effect of this workflow.
Yeah, one question here. For example, if I had a timer or any kind of trigger for the workflow, if I try to use the testing functionality, it will actually wait for the trigger. It will not automatically execute the trigger.
Yeah.
If I put a timer that every 5 minutes, this workflow will execute. And I try to test, it will wait for 5 minutes and it will continue.
Yeah. In theory, that's how it should work.
Yeah, but is there a way to simulate the trigger? Because maybe what I'm trying to do is just to see the flow.
Yeah, exactly. So currently there's no way. So let's say you have a trigger like HTTP endpoint. Let's call it testing. As you've correctly stated, when you now execute this, it will actually wait for the input. What you want is a way to actually have this one continue and maybe provide fake values like
exactly,
some whatever it needs, right? So that's not part of this version, but we do have it on our list to enhance, to have some sort of form input that allows you to provide this input.
Yeah, that would be great.
Yeah, I agree. But we don't have it for now, so for now you will actually have to manually somehow invoke this. So in this case, conveniently provided us with a URL to invoke. So let me come to a new browser, make the request, and it should have continued. It didn't, so not quite stable. You can see with it. The same goes for the timer and message received from, I believe, RabbitMQ messages. But there might be other triggers that don't yet support this, so it's pretty minimal at this point. Personally, I mostly use it just to do quick tests and workflows that don't have any specific triggers. Yeah, it's there for if you want to give it a try.
I have some workflow designs that have triggers, and they trigger every day. I also have a second starting point that listens to, for instance, an HTTP request, so I can manually override the trigger and just start it. These scenarios, so then you get a join later on and wait for any. But that might be tricky in the test scenario, because what is then actually started? Which line do you take to start?
Yeah, great question. I actually don't know what the the logic is. So based on this, it seems like it just takes the first starting activity. So there are 2 starting activities, and it took this one. So I think that's the logic. You don't have control over at this point. What I do want for Elsa 3 at least is to give the ability which activities are starting activities. So it could be 1, could be more, and then the testing should let you choose maybe to trigger when you use the test feature.
Yeah.
But right now
it's great.
It's a little bit arbitrary from the user's point. And of course, one of the things we want to add to this as well is the ability to set breakpoints so that you can execute the workflow, and then as it hits an activity with an active breakpoint, it should pause execution and then allowing you to inspect its inputs. That would be huge to have, especially combined also with a direct view to the console. So in the server we have this console, and it would be pretty sweet if we could stream this somehow to the client, that you get debug messages and that sort of thing. But that's far away still.
Doesn't the journal now provide all the information that you would have as a debug?
Yeah, so there's I think there's an issue for that. Right now it's not implemented, but that is what we want. We want to see the journal. When you test here, you should be able to view its execution log and then have to go to the workflow instance and watch it from there. That's quite inconvenient. So this is what you want to see as well.
Yeah, but that's going to be basically the same. So I was wondering what is the necessity of having breakpoints, because you can't alter things, I guess. That you manipulate the data that it is editing, and when it's just done, it provides the same data as the breakpoint at that point.
Yeah, that's true. You will see the same data, so you might as well just let it run through and then retroactively inspect. But being able to change values at runtime, maybe it is possible if we allow to do so. Because
that would make sense for the breakpoints. Otherwise, it's just let's run it and see the journal fully.
Yeah, maybe. Yeah, it's a good point, because if if it doesn't add any value, then it's not worth the complexity. Maybe. So it's good to think about that. Maybe you just saved me a ton of hours. Just like that. Yeah. All right. So that's all I had for now. Let's take one more look at the Git commit, see if there's something else that's worth mentioning. I'll just mainly V3 stuff and this new feature. All right. Well, then we can cut this meeting short, and then hopefully we'll see these two next time. And of course, anyone comes up with an interesting topic or some demo that they would like to see, then please make that suggestion.
Will do. Thank you.
All right. Thanks, guys. Appreciate you being here. I will see you all next week.
Thank you. See you.
Take care, everyone.
Bye bye.